If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So in this lecture again we will be solving 5 questions starting from question number 66 to 70. Okay, then let's solve these questions. Okay, if you come to question number 66, what is asked here? Keeping in view the requirement of parallel operation, which of these three phase connections given below are possible? So for parallel connections of these, there are different vector groups. So if I write the vector groups, that is first group, if I write, that is 0 group, actually group 1, the first group, that is of 0 degree group. So what are the 0 degree groups? So that the displacement between primary and secondary, that should be of 0 degree, that is y0, means primary is also star, secondary is also star, d0, or you can also have d then zigzag 0. So that 0 means there is no phase difference between these. This is in your first group. So if you come to group 2, second group is 180 degree shift, that is y6. 6 means it is of from time clock. So 6 means it is 12, it is 6. So 1 is at 12, 1 is at 6 means it is, you can see 180 degree shift. 0 means it is 0, actually you can say from 6. 6 means 180, 0 means it is no phase difference. And it is dd6 can also be, or d zigzag 6. Then third vector group was minus 30, that is yd1, dy1, yz1. So in fourth group it is a plus 30 degree shift, it is yd11, dy11 or yz11. That is 11 means this is at 11 and this, so it is plus 30 degree. This is 0, this is 11. This is 1 means this is at 0 and 1 is at 1. So it is minus 30 degree. You can see primary at 0, secondary at 1. That is the meaning of this. Now for parallel operation, it should be of same group. That means group 1 and group 2. Any two you take from group 1, any two you take from group 2, that is okay. Any two from group 3, any 3 from group 4 will be okay. But for third and fourth group, there is also possibilities that you can interchange these two. That means you can take one from third one and one from fourth, and then, but for that you have to reverse the connection, you have to do something modification in the connection. That means dy11 can be connected with yd1 also or dy1 also. So that is possible if you change this yd1 also. That is possible from this to this, but for that you have to be very careful with the connections. You have to change, in some cases you have to change the phase sequence also. So you can see now this question in the options, it is delta delta to star delta. So this is 0, this is either plus 30 minus 30 depending on what connections you are giving. That possibilities are the delta star means it can be minus 30, it can be plus 30 also, depending on whether it is dy1 or dy11. So 0 to 30 it is not possible. First to third combination is not possible. Then delta, again 0 to star to delta can also be either this or this. So again 0 to third or 0 to fourth is not possible. This is 0 0, you can say ddyy. So 0 shift, or either it can be 60, 180, 180. So it is possible. And from star to delta, from delta to star, that means again that depends on what connections you are giving. It should be then y1. If you are taking star delta or delta star, if you want to make it parallel with star delta, then the connection should be 1 1. And if it is 11, then you have to do some modification, 1 and 11. So without any modification, without seeing what is there, it is always possible. 0 0 within 0. That means within first group, within second group. So star star and delta, because there will be no change in angle. This 180 shift, that can be done if you change the phase sequence. Otherwise, it is always 0. So it is possible. So the common answer will be, obviously it should be option C. This is also possible D, but with some modification in the connections. But these two are not at all possible, option A and B, because option A they are talking about first group is linking with third and fourth. First cannot be linked with third, fourth. Second cannot be linked with third, fourth. 3 and 4 can be linked together, but with some modification in the connections. Next, if you come to 67, the low voltage winding of 400 by 230 volt single phase 50 Hz is to be connected to 25 Hz. The supply voltage should be okay. So transformer, you know, it is always a constant flux machine. So this is of primary and secondary. This is 400 and this is 230. So it is connected to a 25 Hz supply. So what should be your supply voltage? That means this side, because supply is coming from this side now, because it is connected, it is not. So what should be this voltage, so that the transformer should operate? Now transformer, you always remember, it is always proportional to V by F. And transformer is always a constant flux. This has to be maintained constant flux. So this ratio has to be maintained. So V1 by V2 should be equal to F2 by F1. So initially it was 230 rating, you don't know which one should I apply, and it was 25, original was 50, now it is 25. So what it should be, you can easily find out, it should be 115. That means your supply voltage should be 115 volt, then it is possible. So that's why this is the answer. So V1 by V2 should be equal to F. This ratio you have to be checked always. This ratio has to be constant in a transformer because it is a constant flux machine. So the answer is 115, that is option C. Now if you come to question number 68, a voltage V is equal to this is applied to a single phase transformer on no load. If the no load current of the transformer is this much, then the magnetization branch impedance will be. So what is the no load current? No load current is required for the magnetization branch only. So if your magnetization branch current is this is given, because this is your equivalent drawing you can see of transformer. So this is your magnetization branch, this branch, and this is for core loss, this is for branch. So if I take this branch, if you know this voltage and no load current is it is mainly depending on your magnetization branch impedance. So your what will be your, then this impedance will be equal to Z equal to V by V by current. So what is V? V is equal to 400 by root 2 at an angle of 0. If I go to phasor, then RMS value is 400 by root 2, same 2 by root 2 at an angle of 85. 2 by root 2 at an angle of minus 85 because it is lagging. Transformer, it is almost 90 degree, you can see it is 85. So it will be 200 at an angle of 85, that is your option C. 3 single phase transformer, 3 phase transformer bank consists of 3 identical 2300 by 230 volt 15 kV single phase transformer connected in delta delta. The bank supplies a 20 kVA unity power factor load. If one of the single phase transformer develops a fault and is removed, the load carried by each of the two transformers now operating in open delta will be how much? Now if you see this one, each one is of 50. Don't think that total will be 3 into 15 45. No, not like that. Actually they are connected in delta. This is one single phase transformer, this is one single phase transformer, this is one single phase transformer. So now it is connected in delta. So what in delta it will be, it will be of C. But if when it is a single phase, then the whatever the line current, that current, because here phase voltage line voltage is same in delta connection. Suppose it was single, initially suppose this coil I take, so it is connected between phase A and B. If you connect in delta also, it will be between A and B. So voltage remains same, but current, if you take it separately, suppose if I connect it separately without this connection, then whatever the line current is, the same current is flowing here. But here if you connect it now delta, whatever current is, the same current is not flowing because it is line current, it is phase current, that will be 1 by root 3 times. So if you take now power, so because your current getting root 3 times voltage is same, so power is basically, it should be 3 into 15, but it divided by 1 by root 3. So if you do this one, it will be equal to around 26 kVA. Okay, so it is supplying 20 kVA unity power factor, that means 20 kilowatt load. Okay, so it can supply because your total is this, but they are identical. Because they are identical, exactly identical, so it is simple parallel operation of two transformer, connected in parallel. You can think of in that way. So the loads will be divided equally now because they are of identical. So the total load is 20 kVA, so each one will develop now 20 by 2, that is 10 kVA. So this is the answer. If you come to question number 70, the law of electromagnetic induction, Faraday's law and Lenz's law are summarized. So you know which one. Lenz's law will give you the negative sign because it is the mother killer. It will kill from where it get generated. dψ by dt, change in flux linkage, will be the EMF induced. That is Faraday's law of electromagnetic induction. Lenz says the induced EMF will be such that it will try to oppose the cause of its creation. That means it will kill its mother. So Lenz's law is also known as mother killer. So that's why this minus sign is there. So 70 is option C. If you like the video, then press the like button and please give your valuable comments in the comment section.